Hi everyone! Today we're talking about surface area of different three-dimensional shapes. Just so you know, the surface area is the sum of the lateral area and the area of the base or the bases, depending on how many there are. So here are your formulas for surface areas. For a prism, since it has two bases, you have to add the area of the base twice. Similarly, same thing works for a cylinder. For pyramid and cone, notice you only have to add the area of the base once. Depending on the base of the pyramid, this formula might change, whether the pyramid is a square pyramid, a rectangular pyramid, etc. And then finally, the formula for a sphere, you can see here. Note, here are all the abbreviations that I'm using in these formulas. Let's do an example together. It says, find the surface area of the rectangular prism shown. So I know the formula for this, it's a prism, is lateral area plus 2 times the area of the base. In this case, the base is a rectangle. And I know the lateral area is going to be perimeter of base times height. So I have perimeter of base times height plus 2 times the base times the height for the base, okay? Now the base of this prism is this rectangle here. It might help you to highlight it or something and label your variables. Now this is the base and the height for the base. This is the height for the prism. So don't get that confused. Next we're going to substitute in our values. So the perimeter of the base, we would have 6 plus 4 plus 6 plus 4. In other words, 6 times 2 plus 4 times 2. Times the height. The height of this prism is 9 feet. Plus 2 times the area of the base. Now the area of the base is going to be 6 times 4. Because that's the base and the height of the base. Next we can simplify this. So we can simplify this down to 180 plus 48, which is 228. And to finalize our answer, we need to say surface area is 228 and use units feet squared. Alright, I want you to try the practice problem below. Here's the correct answer. This one had a base that was a right triangle. Next, we're going to try surface area of a cylinder. I've already written out the formula. Let's substitute in the radius. If the diameter is 15 millimeters, that means the radius is 7.5 millimeters, half the diameter. The height of this cylinder is 18 millimeters. Again, the radius is still 7.5 squared. Now, if we wanted to simplify this first, we could do all the calculations without pi in our calculator. So we would get 270 pi plus 112.5 pi. And we could combine that to give us an exact answer, 382.5 pi. However, we could also get an approximate answer because the question told us to round to the nearest tenth. So I'd type it in with pi to my calculator. And then my answer, I would want to round it off to the nearest tenth and include units. Alright, I want you to try the practice problem shown below. Here's the correct answer for that one. Next, we're going to do the surface area of a pyramid. The equation is given. We're going to substitute in our values. The first step is to find this length here. Now this length is going to be half of 12, so this is 6. That will help us to find the slant height. I know that 6 squared plus 16 squared should equal the slant height squared. When we solve this, we want to take 16 squared plus 6 squared on our calculator, that's 292. And to get the slant height L by itself, we'll have to square root both sides. So we get L equals the square root of 292. Alright, so now let's substitute into our formula. We have 1/2 perimeter of the base. For the perimeter of the base, this is a square pyramid, so we'll have 12 times 4. Every single side, all 4 sides are 12. And L, we just found, is square root of 292. Next, we have to take plus the area of the base. I know the base is a square, so it's the side squared, so 12 squared. Now to solve it for the surface area, if we wanted to get an exact answer first, I could multiply 12 times 4 times 1/2 first. That gives me 24 square root of 292 plus 144. Now, if I want approximate area, I can plug it into my calculator, and the answer should be 554.11. My answer with units is that the surface area is equal to 554.1 centimeters squared. Alright, I want you to try the practice problem shown below. Here's the correct answer. Now we're going to work on a cone. It says find the surface area of a cone with a diameter of 14.8 centimeters and a slant height of 15 centimeters. This already gave us the slant height L. The diameter will help us find the radius. If the diameter is 14.8, that means the radius is 7.4. So I can substitute into my equation. I get pi times 7.4 times 15 plus pi times 7.4 squared. To solve it, surface area is already by itself, so I can go ahead and plug into my calculator. For an exact answer, your answer would be 111 pi plus 54.76 pi, which is exactly 165.76 pi. But if I wanted an approximate answer, I could multiply by pi on my calculator to get 520.75. So my answer plus units is that the surface area is equal to 520.75 centimeters squared. Okay, let's use surface area of a sphere. Let me show you how this will work. Now on this one, I already am given the radius is 6. Remember the formula, 4 pi r squared. So I can go ahead and substitute in. This one's pretty straightforward. Substitute the 6 in for the radius. To solve, the surface area is already alone, so I can go ahead and plug it into my calculator. If you wanted to get an exact answer, you could do the 6 squared times 4 first. That's 144. And then keep the pi on the end. If you wanted an approximate answer, you could plug it into your calculator. You would get 452.4. So our answer with units, surface area of the sphere is about 452.4 centimeters squared. Okay, I want you to try the practice problem shown below. Here's the correct answer. And finally, I want you to reflect on this question. It says, a cone and a square pyramid have the same surface area. If the areas of their bases are also equal, do they have the same slant height? Explain your thinking in 1 to 2 complete sentences. Drawing a picture will probably help you out here. That's all I have for you today about surface area. Tomorrow we will learn more about volumes of three-dimensional shapes. Talk to you then.